Something changed. You noticed it slowly at first. An ad here, a banner there, slipping through what used to be an invisible wall. Then more. Then the autoplay videos came back. Then the pop-ups. Then the tracking banners you hadn't seen in years started reappearing on websites you visit every single day. And you did what everyone does. You went to your ad blocker's settings, checked if it was still enabled, refreshed the page, maybe reinstalled the extension entirely. And it still didn't work the way it used to. What you experienced wasn't a bug. It wasn't your ad blocker breaking down. It wasn't the websites getting smarter, though some of them have. What happened was a deliberate, years-long, carefully engineered change to the foundation of how Chrome extensions work. A change that Google designed, pushed through over enormous opposition, and quietly implemented in the browser used by roughly 2/3 of every person on the internet. And the reason they did it has everything to do with the fact that Google's entire business model depends on you seeing ads. Let me show you exactly what happened, why your ad blocker lost its power, and what you can actually do about it right now. To understand what changed, you need to understand how ad blockers worked in the first place, because the mechanism is actually elegant, and understanding it makes what Google did to dismantle it much clearer. When you install an ad blocker like uBlock Origin or AdBlock Plus as a browser extension, that extension operates by monitoring every single network request your browser makes as it loads a web page. Every time a web page tries to fetch something from the internet, an image, a script, a video, a tracking pixel, an analytics library, your browser sends out a network request to retrieve that resource. Ad blockers work by intercepting those requests before they complete and comparing them against lists of known advertising and tracking domains. If the request is heading toward a domain that's on the block list, say a Google advertising server, a Facebook tracking pixel, or a third-party analytics service, the ad blocker cancels that request entirely. The resource never loads, the ad never appears, the tracker never fires. The page loads cleaner, faster, and without the surveillance infrastructure that modern advertising depends on. This mechanism is called request blocking, and for over a decade it was the backbone of how virtually every serious ad blocking extension operated. It was powerful because it operated at the network level. It didn't just hide ads visually by making them invisible with CSS tricks, it actually prevented the ad infrastructure from loading at all. This meant trackers couldn't collect data, even if they wanted to, advertising scripts couldn't execute, and the performance benefits were real and measurable because your browser wasn't spending time and memory downloading and processing dozens of advertising and tracking resources on every page load. Studies consistently showed that ad blocking reduced page load times by anywhere from 20 to 50% on ad-heavy websites, and reduced data consumption proportionally. Ad blockers weren't just about avoiding annoying banners. They were meaningfully improving the performance and privacy of the browsing experience. Google watched all of this happening, and from a technical perspective, Google understood exactly how it worked, because Google builds Chrome, and therefore, Google understands every API and interface that extensions use to interact with the browser. And at some point, the internal discussions happened years before the public announcement. Google's engineers and product teams arrived at a proposal that would fundamentally restructure how Chrome extensions interact with the browser. That proposal was called Manifest Version 3, or MV3. And the way it was initially framed to the public tells you almost everything you need to know about the politics of what was actually happening. Google's public justification for Manifest v3 centered on security and performance. The argument went like this. The existing extension system, called Manifest v2, gave extensions too much power. Extensions running under MV2 could execute arbitrary code, intercept and modify network requests dynamically with enormous flexibility, and operate with a level of access to browser internals that created security risks. A malicious extension could do serious damage under MV2. Manifest v3, Google argued, would create a safer, more performant extension ecosystem by limiting what extensions could do, requiring them to declare their behavior up front rather than executing dynamic code at runtime, and replacing certain powerful APIs with more restricted alternatives. All of this sounds reasonable in isolation. The security concerns about extensions are real. Malicious browser extensions have been used to steal passwords, inject cryptocurrency miners, hijack search results, and worse. But here is the part that Google's public communications consistently downplayed and that the developer community immediately identified as the critical issue. The specific API that Manifest v3 restricted most severely was the Web Request API, the exact API that ad blockers use to intercept and block network requests in real time. Under MV2, the Web Request API allowed extensions to intercept a network request, inspect it, and block it dynamically based on whatever logic the extension chose to apply. Under Manifest v3, this dynamic blocking capability was replaced with a new API called Declarative Net Request. The difference between these two APIs is the difference between an extension that can make decisions about network requests in real time with full flexibility and an extension that has to declare a static list of rules up front that the browser then executes on its behalf. Under declarative net request, ad blockers cannot write custom logic to handle network requests. They can only provide a list of rules, essentially a simple block list, that the browser checks against incoming requests, and critically, that list of rules is capped. Google initially proposed a cap of 30,000 rules per extension. After significant outcry from developers, this was eventually raised to 30,000 static rules plus 5,000 dynamic rules, with a total limit across all extensions of 330,000 rules. Why does that cap matter so much? Because modern ad blocking works with enormous, complex, regularly updated lists that contain hundreds of thousands of rules. EasyList, one of the most widely used filter lists in ad blocking, contains well over 70,000 rules on its own. uBlock Origin, the most respected and technically sophisticated ad blocker available, uses multiple filter lists simultaneously that together contain hundreds of thousands of rules, far exceeding what Manifest v3's limits allow. Compressing all of that filtering capability into the hard rule limits imposed by MV3 means that a significant portion of the blocking capability that MV2-based ad blockers had simply cannot exist in an MV3 extension. Not because the extension developer didn't want to implement it, but because the browser literally prevents it. The developer community's response to this was immediate, sustained, and scathing. When Google first published the Manifest v3 proposal, the comments and feedback from extension developers, privacy researchers, and security professionals were overwhelmingly critical. The Electronic Frontier Foundation, the nonprofit digital rights organization, published a detailed analysis calling Manifest v3 a significant step backward for privacy and security for users, noting that the changes would make it harder for extensions to function as privacy tools, while the claimed security benefits were questionable, because truly malicious extensions had other ways to operate that MV3 wouldn't necessarily prevent. The EFF titled their piece Chrome's Manifest v3, or is deceitful and threatening. Not exactly measured language from a usually careful organization, but it reflected the level of alarm in the technical community. And it maintains support for MV2 extensions, including full uBlock Origin. For users who find the Firefox interface unfamiliar, Brave offers a very low-friction migration path from Chrome while dramatically improving ad blocking and privacy capabilities. Now let's talk about what websites themselves have been doing in parallel with all of this, because the Google Chrome Manifest v3 story is only one dimension of why your ad blocker has been less effective. Independently of what Google did with Chrome, publishers and advertising networks have been developing increasingly sophisticated anti-ad blocking techniques that challenge even the most powerful MV2 extensions. One of the most effective and widely deployed is called server-side ad injection, or sometimes first-party ad serving. Traditional advertising networks served ads from third-party domains: Google Apps, .com, DoubleClick, Net, Facebook. Net that ad blockers could easily identify and block because they were on well-known block lists. But increasingly, publishers are proxying their ad content through their own first-party domains, making the ad requests appear to come from the same domain as the content you're trying to access. When an ad request comes from the same domain as the website you're visiting, ad blockers face a much harder challenge. Blocking that request risks blocking legitimate content from the same domain: images, scripts, and other resources the page actually needs to function correctly. Sophisticated ad blockers can still identify these requests through behavioral analysis and other heuristics, but it requires more complex and computationally expensive logic that, again, is harder to implement under MV3's constraints than under MV2. Another technique is called anti-ad block scripts, JavaScript that websites inject specifically to detect whether an ad blocker is active and then either prompt the user to disable it, prevent access to content, or serve alternative content. Major news sites, streaming platforms, and entertainment sites have deployed these scripts widely, resulting in those messages you've probably seen asking you to whitelist the site or disable your ad blocker to continue accessing content. These scripts work by looking for the telltale signs that an ad blocker is present: the absence of certain advertising resources that should have loaded, the presence of specific DOM modifications that ad blockers make, or the blocking of certain tracking calls. uBlock Origin under MV2 had robust capabilities to neutralize many of these anti-blocking scripts through scriptlet injection, injecting small scripts of its own that neutralized the detection logic. This capability is significantly curtailed under MV3. There are also DNS-level blocking solutions that operate completely independently of the browser and therefore are unaffected by Manifest v3 entirely. Pi-hole is the most well-known. It's a DNS sinkhole that you run on a device on your home network, typically a Raspberry Pi mini computer, that intercepts DNS queries from every device on your network and blocks requests to known advertising and tracking domains at the network level before they even reach your browser. Because Pi-hole operates at the DNS layer rather than the browser extension layer, it is completely immune to anything Google does with Chrome's extension system. It's more technically involved to set up than a browser extension, requiring you to configure your router or individual devices to use it as their DNS resolver. But for technically inclined users, it provides a level of network-wide ad blocking that no browser extension change can touch. Similarly, NextDNS is a cloud-based DNS filtering service that provides Pi-hole style blocking without requiring you to run your own hardware. You configure your devices or router to use NextDNS as their DNS resolver, set up your blocking preferences through a web dashboard, and NextDNS handles the filtering from its infrastructure. It works across all browsers and all apps on any device pointed at it, and again it operates entirely below the level where Manifest v3 has any relevance. For the most privacy-conscious users, combining a DNS-level blocker with a browser-level extension in a privacy-respecting browser creates a layered defense that is significantly more robust than any single solution alone. DNS blocking handles the straightforward domain-level requests. Browser extension blocking handles the more nuanced page-level filtering that DNS blocking can't do. And using a browser that hasn't artificially capped its extension capabilities ensures that your browser-level tool is operating at full effectiveness. Let's also be honest about what ad blocking means for the economics of the web, because this conversation doesn't exist in a vacuum, and the publisher side of the argument deserves a fair hearing. Advertising is how a very large portion of the free internet pays for itself. The news site that employs journalists, the independent blog that spent years building an audience, the educational resource that provides free information, many of these operations depend on advertising revenue to survive. When everyone uses an ad blocker, these operations face real financial pressure. Some publishers have responded by paywalling their content, which is a legitimate business decision. Some have responded by deploying the anti-blocking techniques described earlier, which is also a business decision, though a more adversarial one. Some have sought alternative revenue models through subscriptions, memberships, and donations. The distinction that matters most in this conversation is not between advertising and no advertising. It's between advertising that respects users and advertising that surveils, manipulates, and degrades the browsing experience. A static image ad for a product relevant to a website's topic, served without tracking, without data collection, and without behavioral profiling, is a very different thing from the multi-layer tracking ecosystem that modern programmatic advertising represents, where dozens of companies collect data about your behavior across thousands of websites to build profiles used to manipulate your decisions. Many ad blockers, including uBlock Origin, allow users to whitelist specific sites whose advertising they find acceptable, explicitly supporting those publishers while blocking the surveillance infrastructure that operates in the background. The real conversation here isn't ad blocking versus the free internet. It's about who has the right to decide what software runs on your computer and what your browser does with your network connection. Google made a decision through Manifest v3 that restricts what protective software you can run in its browser. That decision serves Google's advertising business interests in ways that are not coincidental and not acknowledged with full transparency. The response available to you is to make an informed choice about which browser you use and which tools you trust to protect your experience online. Your browser is the most important piece of software on most people's computers. It mediates almost every interaction you have with the internet. The decisions made about how it works, what it allows, and what it prevents have enormous consequences for your privacy, your security, your performance, and your autonomy online. Those decisions are not made neutrally. They are made by companies with specific financial interests, operating in a specific competitive landscape under specific regulatory pressures. Understanding those interests, understanding that Google is simultaneously the world's largest advertising company and the developer of the world's most widely used browser, is the essential context for evaluating every decision Google makes about Chrome. Manifest v3 is not a conspiracy. It is a business decision, technically implemented, publicly documented, and rolled out over years with a stated rationale, but a business decision made by a company whose primary revenue source is threatened by the technology being restricted deserves exactly the level of scrutiny it has received. Your ad blocker didn't just stop working on its own, it was made to work less effectively by deliberate architectural choices in the browser you were using. Now you know why, and now you know what to do about it. Switch to Firefox. Install uBlock Origin. Block everything you want to block. Your browser should work for you, not for the advertising infrastructure that funds the company that built it.